We'll study today the control system designer in MATLAB. And to start the control system designer, we'll be using the command SISO tool. We'll see later that in another video, but now let's start with the theory behind it. So what we need to do is we need to calculate or to compute this controller C here, which is in this closed loop transfer function, and we have this feed-forward transfer function, which is 1 over 10s2 plus 11s plus 1. So we need to design this corrector C so that the system meets the following. So the steady state error for a stack response is 0.01 and the phase margin is 45 degrees. So we will see how to solve that and how to get that. So of course, in order to make a steady state error of 0.01, so we need to have a corrector K, which is here. And in order to have a phase margin of 45 degrees, we will see what we'll do. So we will introduce now something which is called phase lead compensator. So this compensator or this controller is written in this form, where f of s is equal to s plus z over s plus p. So it is like a numerator and a denominator where we have 1 0 and 1 pole. And for a phase lead compensator, so whenever we have a leading system, we have that the magnitude of z is lower than the magnitude of p. So in fact, what does it mean? It means that this controller, whenever it is added to our system, it will be generating or it will be adding a phase to our system at a certain frequency. And how to design our controller, we can rewrite f of s in this term, 1 over alpha times 1 plus alpha cs over 1 plus cs. And in fact, alpha will be calculated by this way, 1 plus sine A over 1 minus sine A. And A, which is here, it will be the amount of phase that I want to add to my system. And C, it will be 1 over omega n square root of alpha, where omega n it is the frequency over which I want to add the phase. So let's look a little bit here about the Bode plot of the phase lead compensator. So it will have a diagram like a high pass filter for the phase and for the magnitude, and for the phase it will have a magnitude A. So it is how much I'll be adding phase to my system from here to here, and this phase will be added to some frequency omega n.